All right, I've got a bonus multiple choice review video for you for chapter 1. So these problems come from the chapter review that is at the end of chapter 1 in our textbook. So these problems are out there. You can go look at them. You can find the answers floating around on the internet. So these aren't anything special. These aren't like actual old AP Stats exam multiple choice questions, but they, I would say, are fairly similar to ones that you would expect to see on the chapter test. So the first problem says you record the age, marital status, and earned income of a sample of 1,463 women. The number and type of variables you have recorded is. So we have so many quantitative versus so many categorical. So we need to be able to take these variables. And number one, how many variables do we have? Well, we have age, we have marital status, and we have earned income. So we have 3 variables altogether. So whatever the breakdown is should add up to be 3 total variables. So automatically we know it's not E, that adds up to be 4 variables. It might be D. It can't be C because again that adds up to be 4. Can't be B, that adds up to be 4. Or it could be A because those technically add up to be 3. So is it 3 quantitative and no categorical or 2 quantitative and 1 categorical? We got to remember that quantitative variables are variables that would deal with numerical values, and not just any numerical values, but particular ones it would make sense to do math with. It would make sense to add things together. So if we talk about ages, would it make sense to calculate the average age of a group of people? And it would. So I'd say age is a quantitative variable. Now, marital status, is that numerical in nature? And marital status would just be single, married, divorced, widowed, and that is categorical. And earned income, we're talking money, that's definitely going to be something that's quantitative. And after we get to the marital status and we know it's categorical, we know the answer's got to be D. All right, question 2. Consumers Union measured the gas mileage in miles per gallon of 38 vehicles from the same model year on a special test track. The pie chart provides information about the country of manufacture of the model cars tested by Consumers Union. Based on the pie chart, we conclude, and so we're just going to have to go through these 5. There's going to be nothing like the last problem where we can start easily crossing off options. We're just going to have to read all these and see which ones make sense and which ones don't. Now, when I look at this pie chart, I need to really first understand what the slices represent. Okay, the slices represent, we can see countries here. But what exactly are we referring to? And you got to keep in mind, they said this represents 38 vehicles, and really they're just telling us where these 38 vehicles were made at. That's all what these countries mean here. So in part A, when they say Japanese cars get significantly lower gas mileage, this pie chart is not measuring gas mileage. It's measuring where do the cars come from? So do we know, just based on this pie chart, that Japanese cars get lower gas mileage than cars from other countries? And we don't. We're missing that information. So when they said that they measured the gas mileage in miles per gallon, that would need to be on like a histogram or a stem plot or a dot plot or a box plot, not in a pie chart. It's the wrong type of data. Okay? So it's not A. B, U.S. cars get significantly higher gas mileage. I don't know about what the gas mileage is. Now, I think some people would blindly look at this and go, hey, U.S., it's the biggest slice. We're number 1. And so, yeah, that must be true. But that just means over half of the cars, right? This is over half the circle here. Over half the cars of the 38 vehicles were made in the United States. That's really what that slice is saying. So again, when they talk about the gas mileage, I can't say that for sure. I don't know what the gas mileage is. So it's not B. C talks about gas mileages. I don't know what the gas mileages are. D, Mercedes, Audi, Porsche, and BMW represent approximately a quarter of the cars tested. I don't know which car. Like, do they want me to go research? Where are Mercedes cars manufactured? Where are Audi cars manufactured? Where are Porsche? Where are BMW? I don't know exactly where these are really from. So can I conclude that from this pie chart? No, I cannot. Now, E, more than half of the cars in the study were from the United States. And we mentioned that earlier when we were looking at Part B. We do know that over half the cars were from the U.S. This is over half the pie chart. So E is the correct answer. So definitely a tricky one because they really want you to think this pie chart is all about gas mileage. But gas mileage has nothing to do with this pie chart. Number 3, which of the following bar graphs is equivalent to the pie chart in question 2? So I have these all stacked on each other, and we're just going to kind of go through them one at a time. If we can easily eliminate one, we'll throw it away. If there's one that we think is plausible, we'll hold on to it, and we'll go look at the next one. All right? Okay, so one thing that catches my eye here is that Germany and U.S., they look about even here. And if I were to go look at the U.S. and Germany pie slices, do they look like they're about even? And I would say, no, they do not look like they're the same. So I'm fairly confident A is not the correct one. Now, I notice here, U.S., whoa, commanding lead here. Definitely looking good. But then maybe I go look at the next slice. The next biggest slice is Japan. Is that true in the pie chart? Or not pie chart, bar graph. Yes, Japan is the second one. Then Germany, I'd say, is the third big slice, and that's true in my bar chart. What's next? Sweden. Does Sweden look like it's next out of the remaining? It does. France and Italy, they look like they're about the same, and yeah, that looks pretty good, I think. Now, I didn't verify, with any numbers here if this really, really matches up. So what I want to do is save B. I'm going to put it off to the side here. And then look at C. So let's see. C says Japan is the greatest one. And we know U.S. is number 1. Come on, Japan, get out of here. All right, D, U.S. number 1 works. Japan, number 2, yeah. We said Germany was third, but Sweden looks like they're third. Looks like even Italy's before Germany. Things aren't matching up there. So D, I'd say, let's throw it out. And there's only 4 options. B is our winner. Number 4, earthquake intensities are measured using a device called a seismograph, which is designed to be most sensitive to earthquakes with intensities between 4.0 and 9.0 on the Richter scale. Measurements of 9 earthquakes gave the following readings. And so we can see we've got some numbers in here, but there's also some L's and some H's. That's kind of weird. So then it indicates where L indicates that the earthquake had an intensity below 4.0, because remember it said this works great for intensities between 4.0 and 9.0. So L just means it wasn't quite 4.0. And H indicates that it was above 9.0. So we had something greater than 9, but we don't know what it is. The median earthquake intensity of the sample of these readings here. How many were there altogether? There were 9 earthquake readings. So the median would be the middle value when the 9 earthquake readings are in order from least to greatest. So don't just look through here and go, where's the middle value? Hey, it's 8.7. Cool. Oh, look, it's D. And I'd go, no, that's not in order. There's a chance it could be 8.7, but first we have to put these in order. So the smallest value would technically be the L. The L takes the L. And then, what do we got? 4.5. So I'm just going to start crossing these off here as I'm working along. 5.2 is next. 5.5. And then 6.0. Now, ultimately in the end, I don't really need to come up with all of them. Let's see, what's there? There's 4 left. So it'd be 1, 2, 3, 4. Because the middle one would be the 5th of the 9. And so even if I were to go put all the others, I know there's 2 H's up here at the very, very end, and then I've got the 8.7 and the 8.9, but who cares? If I know which value, which numbered value would be the median, I can just stop there and say it's going to be 6.0. So the answer is B, which is kind of weird. Why did they do 2 decimal places and not just 1 decimal place? Very odd. All right, 5 and 6 are going to use this histogram. And it says, in a statistics class with 136 students, the professor records how much money in dollars each student has in his or her possession during the first class of the semester. The histogram shows the data that were collected. So you can see more than enough people had less than $10 in their pocket. Now, that may be $0, but it's all the way up to, but not including $10. So if they had a $10 bill in their pocket, then technically they're going to go in this second bin. So this is really 0 up to $9.99 goes in this first bin. Then $10 up to $19.99 go in the second one. So each number you see here is really the minimum value for the next bin. All right. And the way I remember that is really you start at the 0 and say, well, the 0 is going to belong in this bin. And then so the rest have to fall like dominoes in the same order. And you can see, holy cow, who's this kid? He's got a lot of money. Let's see if he wants to take us out to lunch. I don't know. So anyway, the percentage of students with less than $10 in their possession is closest to which of those percentages? So less than $10. Well, that's just this one bin here. And so we look and it's a little bit above 60, right? Like, I don't know, if I had to guess 61, 62, maybe I'll go 62. We'll say 62-ish, all right? And so if you're not paying close attention, you could very easily go, oh, well, there, hey, it says it's closest to 60%. But the numbers on our vertical axis are not relative frequencies. They are not in percentages. They are in frequencies, aka counts. So when we say 62, we don't mean 62% of students had less than $10. We're saying there's about 62 students out of all 136 students that have less than $10. So if we were to take 62 or 61 or 60-ish, somewhere in there, and divide it by 136. Where's my handy dandy calculator? 62 divided by 136 is about 45.5%. What is that closest to? Closest to 50. Now, what would be interesting, though, if they had, instead of, notice it's 30, 35, 50, 60, 70. What if they had said 40% for B? And we're at like 45, and it's probably going to be different if I had said 61 out of 136, and now it's 44.8, and you're going, oh, man, this is kind of in between 40 and 50. So that's why you notice they didn't say 40% here, because it's close-ish to 45%. All right, number 6, same histogram. It says, which of the following statements about this distribution is not correct? So again, we're just going to have to go through this list here and start crossing off the ones that we definitely can identify are wrong. If there's something that is going to take us a little bit longer to figure out, maybe we can save it until maybe we find an answer later on, okay? And then we can just ignore doing more work than we really had to. So A, the histogram is right skewed. That is definitely true, right? And we're trying to find the one that's not correct. So A is not good. B, the median is less than 20. So the median's the middle value. I cannot easily just look at this graph and go, yep, I know exactly where the median's at. We're going to have to kind of do a little digging for this. So here's what I'm going to do. I'm going to say save. And if we need to come back to that one, we can. C, the IQR is 35. Ooh, we need to know the first and third quartiles. And we don't have those numbers. And we don't have the whole data set, right? We don't have all 136 values, all $136 amounts. So can you easily find Q1 and Q3 in a histogram? And again, I'd say let's save this. Let's circle back. Let's keep going. The mean is greater than the median. That we can definitely answer. Since this is a skewed distribution, regardless of, let's take that back. Since it is skewed, the mean and median are going to be different values. And since it's skewed right, we know the mean, why did I write it S? The mean is going to be chasing the tail down here, which means the mean in this case is going to be greater than the median. So if the mean is greater than the median, that is a true statement. It is not a not correct statement. Answer choice E, the histogram is unimodal. Unimodal, what did unimodal mean? Unimodal? One hump, right? It's got one mode. Does this just have really one hump of data? And I could see some people going, nope, look, it comes down, and then it comes up. Oh, and then it goes down, and then it comes up. There were 3 humps in there. That's trimodal. And I would say that's kind of a bit of a stretch. I would not call that trimodal. I wouldn't even call it bimodal. I wouldn't call this one hump, and then we get nothing, and then we get a little baby bump down there at the end. I'm just calling this overall unimodal. So I would not say that is not true either. I would call it unimodal. It is a skewed unimodal right-shaped distribution. There we go. So now it's got to be one of these two. It's either got to be B or C. And if you're running out of time and you're like, I don't know, I don't know what to do, you got a 50-50 guess now if you had to guess. Now, I would definitely say the median is going to be easier to figure out than the IQR, because we got to realize IQR, we have to figure out Q1 and Q3 versus the median, that's just one number. So let's shoot for the median. Now, if I have 136 students, I need to think about how this number is going to break down, because the median's the middle number, right? So if I were to split this 136 in half, 136 divided by 2 is 68. Okay, so we got 68 and 68, which means the median is going to be the tie between the 68th and the 69th student, who would be the first person in the second group of 68. So I need to figure out, where is the 68th and 69th student at in this histogram? Now, what I can do here is use the frequencies, right? These are the counts. So this first one, between $0 and $10, that looked like it was, 61? So we've got 61 students. The first 61 students have less than $10. And remember, we're trying to find, where's the 68th and 69th student? They're not here yet. But once I add on and look cumulatively at how many students have less than $20 in their pocket on the first day, this looks like it's about, is it right at 40? Yeah, we'll call it 40. So how many students have less than $20 in their pocket? It looks like about 101 students. So where would I have come across the 68th and 69th student? Somewhere within this second bar. So that's telling me the median is somewhere between 10 and $20. So is it true that the median is less than $20? It is true. It is less than 20. It's actually between $10 and $20. I can even be more precise than that. So B is not correct. So that leaves me with answer choice C. Now, if you're wondering, how do I figure out Q1? How do I figure out Q3? You would need to take those 68 people. This is where it gets a little bit trickier. But we're really going to find the median of the first and the second half set of data. So if we think of splitting 68 into 34 and 34, then Q1 would be the tie between the 34th and 35th student, which would mean they're somewhere between $0 and $10. And in the second half, this is where it gets trickier, because now we need to, it's not just going to be 34 and 34. We kind of need to cumulatively think about where we're at there. So if I want to go 34 students below 136, that'd be 102. So which one am I going to go here? So between the 102nd and 103rd students, that would give me Q3. Now, I can either keep going forwards until I get to 102, 103, or it might be easier to go backwards and say, by the time I get to $100 and $110 in this range right here, I know I've got all 136 students. And so this one, maybe this is one student. This looks like it might be, 3. This might be 1. This might be, 6. So right there, I've gotten, 11 students have somewhere between $30 and $110. And I need to be able to go down 32 students. This is about 20. There's about 31 students. Again, I need to go 32 down. So I think Q3 is between $10 and $20. So could I say it's 35? If I think Q1 is between 0 and 10 and Q3 is between 10 and 20, I think the IQR is going to be more about, $10 to $20. I don't know exactly for sure because I don't have those exact numbers, but it's somewhere between $10 and $20 in the end when I subtract Q3 and Q1. So that is definitely not correct, that it's just 35. All right, number 7. 40 students took a statistics examination, having a maximum of 50 points. The score distribution is given in the following stem and leaf plot, or stem plot. Some textbooks may call it stem and leaf. We just call it normal stem plots. And you might be going, yeah, but isn't this from our book? Why are they calling it stem and leaf? I don't know. You can call it either way. The third quartile of the score distribution is equal to, so they want to know, what's Q3? And you'll notice right off the bat here, we got three numbers that are one away from each other. And then we got a number in the 30s and a number in the 20s. If I was a betting person, I'm going to bet it's probably not D or E. And if I'm also looking at my data, the third quartile means I am 3/4 of the way through my data set. And so I'm thinking I got to be somewhere, probably up in the 40s, which again, kind of verifies that it's probably not going to be 32 or 23. All right. Now, how do you get it exactly? Well, do you remember kind of what we did on that last problem? You could kind of do that with 40 values, and you could split it up and we could go 20, 20. But then we're going to split up. This would give us, 10 and 10. So the 10th and 11th, the tie between the 10th and 11th is Q1. But then we got to go look at the other 10 and 10. So really it is the tie between the 30th and 31st student would be Q3. So you could go find where's the 30th and 31st student and what's in between those two values, and you got it. Now, I would do, since I have all of the data here, is I would just quickly punch these into a list. And you might go, yeah, but it's 40 values. Do you want to be for sure? Or do you want to kind of play around with these like ties between even numbered data sets? It's really up to you. Go put the numbers in list 1. Go do some one variable stats, scroll down to the bottom, and guess what it's going to tell you for Q3? That Q3 is equal to 44. And the correct answer is B. All right, number 8. The mean salary of all female workers is $35,000. The mean salary of all male workers is $41,000. What must be true about the mean salary of all workers? So a very common misconception would be just to say, let's find the average of 35 and 41,000. And that would come out to be $38,000. And then some people will say, yeah, it must be $38,000. But that would only be true if there were as many female workers as there were male workers. And they didn't specify how many female workers there were and how many male workers there were. Okay? So if you think about it, let's play with small numbers here. Let's say there's only one female worker and she makes $35,000. So what's the mean of $35,000? $35,000. So let's say that one female worker makes $35K. And let's say, for the sake of argument, that there were 2 male workers. Okay? And let's say one of them makes, well, again, we'll make these numbers nicer here. Let's do 40 and 42,000 because the mean of 40 and 42 would be 41. Cool. So now, what's the mean of 35, 40, and 42,000? So if I were to grab my calculator, 35 plus 40 plus 42, and then I got to divide that by 3 people altogether. That gives me 39,000. So must it be 38,000? No. So now we got to look at some other options here. So it must be larger than the median. Do we know what the median salary is? They told us the mean and the mean, but I don't know what the median salary is. So I can't say that for sure it must be true. It could be any number between 35,000 and 41,000. Well, we got 39,000, which is between 35 and 41. So that seems plausible, right? So maybe we'll hold on to that one. D, it must be larger than 38. Well, again, we got 39, but could it be smaller than 38? And it could, right? So in this situation, I had 2 male workers and 1 female. What if I had more female workers than I had male workers? Well, guess what's going to happen to the mean? It's going to be closer to the female average than it will be to the male average. So it will actually be smaller than what's in the middle, 38. It cannot be larger than 40,000. So I would say this could happen. And that would be, what if we had, let's say, 200 male workers and they all made, let's all say every single one of them made $41,000. And then we have this one female worker that made $35,000. So if I had, let me clear this out here. If I had 41,000 times 200 male employees plus an extra $35,000 for that one female employee, divided that by 201 total employees, well, the average is $40,970. That is larger than $40,000. So it can be larger than $40,000. So honestly, it could be any number between the female average and the male average. It just depends on how many females and how many males there are altogether. All right, 9 and 10, and then there's a question 11. There's a bonus question. So we're going to use this two-way table. And this problem is about a survey designed to study how businesses operations vary according to their size. Companies were classified as small, medium, large. Questionnaires were sent to 200 randomly selected businesses. Since not all questionnaires in a survey of this type are returned, researchers decided to investigate the relationship between the response rate and the size of the business. So some businesses responded, some did not, and they broke it down by the size of the business there. So what percent of all small companies receiving questionnaires responded? So this one, we got to look a little bit into this because they say what percent of all small companies? Are they wanting us to examine and consider all companies? No, only the small companies. So back in an earlier video, we called this a conditional distribution. They don't want us to focus on all of the data. So consider, I'm not blacking these out, but bluing them out. I really want to focus on the small. So only focusing on these 200 companies in particular, what percent actually responded? Well, 125 responded out of 200, and that comes out to be 62.5%. So I very easily could see some people going, all right, well, let's see. There are 600 total companies altogether, right? They got 200 of each type. And so what would be 125 out of 600? I'm going to bet that response is present in this data somewhere. And I'm going to bet it's probably this 20.8%. But since they said of all just the small companies, we don't consider the medium ones or the large ones. Number 10, which of the following conclusions seems to be supported by the data? Again, we're going to have to just kind of go through these one at a time. So A, there are more small companies than large companies in the survey. More small than large. No, there's the exact same amount. So that is not true. B, small companies appear to have a higher response rate than medium or big companies. Well, let's see, response rate 125. And we got to remember, these are all out of 200. So I can directly compare the actual response values here. And that would also represent the response rate, the percentage. So 125 out of 200, 81 out of 200, 40 out of 200. That seems to be true here, right? Since they're all based out of 200, again, we can just compare these. And that would be our answer. So the rest of these would all be incorrect. If you want to go through and see why they are incorrect, you certainly can. But again, once you find the right answer, and if you're sure that's the right answer, you can feel confident to move on. Number 11, an experiment was conducted to investigate the effect of a new weed killer to prevent weed growth in onion crops. Two chemicals were used. We have the standard weed killer, C, and the new chemical, W. Both chemicals were tested at high and low concentrations on a total of 50 test plots. The percent of weeds that grew in each plot was recorded. Here are the box plots of the results. Which of the following is not a correct statement about the results of the experiment? Now again, we're going to have to go through these 5 one at a time until we find the one that is not correct. All right, so A, at both the high and low concentrates, the new chemical W, so that'd be, there's new chemical W, gives better weed control than the standard weed killer C. So do the two orange box plots look like they're shifted? Shifted which way? Percent of weeds that grew. So if it had better control, there would be fewer weeds that would grow. That would indicate better control. So are the two orange box plots shifted further down to the left, roughly, than the two green ones? And I would say, yeah, that kind of looks true there. I would say that's probably a true statement. Now, some of you might go, but these two, this one and this one, they kind of look like they're roughly-ish the same. And I'd say, yeah, I'm still leaning towards, I think these two orange ones are further down than these two green ones overall. So if you wanted to, you could hold on to that one as maybe being a possibility, but I'm not sold that A is really a correct statement, or is not a correct statement. All right. B, fewer weeds grew at higher concentrations at both chemicals. So higher concentrations, we're looking at those, and we're kind of comparing it to the lower concentration. So overall, are these two box plots lower? Are they shifted more to the left than the two box plots in red? And I would say no, that's not really true. All right, so let's examine C. The results for the standard weed killer are less variable. Less variable just means less spread. So we just need to look at how stretched are these. So the results for the standard weed killer, the standard was C. They are less spread out than those for the new chemical. So is there less spread in these box plots than in these box plots? Yeah, there is less spread. That is a true statement. D. Let's clear this off now. High and low concentrations of either chemical have approximately the same effects on weed growth. So does it look like these 4 box plots are really showing the same effect? Or do you believe some of these are better than others, that there actually is a difference in these? And I would say that's probably true. I mean, when I look at this one and this one, there is some overlap in here, but really this one is shifted further down than this one. I feel better that the higher concentration of the standard will do a better job than the low concentration of the standard. So I'm feeling like that one's not correct. It doesn't have the same effects. There is a difference. Let's look at the last one. Some of the results for the low concentrate weed killer, so that's the top 2 box plots. So some of the results for the low concentrate of weed killer W, not both of them, just the top one, show fewer weeds growing than some of the results for the high concentration of W. So some of the results in here show fewer weeds growing than some of the results for the high concentration. And I'd say that's true, right? We can take the minimum versus the maximum. Is it true that this value is smaller, has fewer weeds than this example up here? We'd say, yeah, that's absolutely true. So it can't be E. So it really must be D in the end. And that's all for our bonus multiple choice video.